Hello everyone. Welcome to the next lecture on the PY question series. Today, I will explain you how you can solve the problems related to the uniform continuous. I will explain all those questions from the CSIR NET and the GATE examinations. Myself, Dr. Harish. You can follow my YouTube channel where you can find the playlist of the CSIR NET and previously various lectures on the PY questions on the various topics. All are explained with the help of the shortcut. You must subscribe my YouTube channel so that you can get the notification on my new uploaded video. Now, these two lectures, that is the limits and the continuity, I already explained you in my last lectures. And in this lecture, I will explain you how you can solve out the uniform continuity. Now, before I can directly move on the PY question series, let me quickly give you some shortcut tips so that you can solve each question with the help of the 10 to 15 second time period. But make sure before watching the today's lecture, you have to complete watch on the limits and the continuity topics. So you must watch about my PY questions on the limit and continuity so that you can learn this lecture in a very simple manner. All these lectures are available at my YouTube channel. Now, what are the shortcut tips? If f is a mapping from closed interval to R, fine. Then, in order to prove that f is my uniform continuous, you need to prove that f is continuous on closed interval a comma b. That's the first shortcut tips for you. Whenever you have to a close interval in your domain, then in order to prove whether the function is a uniform continuous or not, you need to prove that f is a continuous. If f is continuous on the closed interval, then it is my uniform continuous. For example, if I say my domain is my this 0, 1 and the function is defined as 1 over x. Now, whether it's a uniform continuous, clearly say this function is not continuous on the closed interval 0 comma 1 because of this 0. That means this function is my not uniform continuous. However, if I say the function is my 1 to 2 from R and the function is again 1 over x. So 1 over x is my continuous in this closed interval, then it is my uniform continuous. Second, if f is a function from a comma b to the R, fine, then you need to prove the two options. First one is you need to prove that f is continuous on the open interval a comma b, and second is limit x approaches a positive and b negative, both must be existence and unique. Fine, whether they are equal to both, they are equal to or not, it may or may not be, but it must be existence. Also remember that in this case a or b may be finite, it may be finite or infinite. Finite, fine. But one simple remembrance that if a and b, if a and b are my finite, then you must need that both are existence. However, if either a or b is my infinity, then this limit of the f x approaches infinity may or may not exist. May not exist. Fine. But if they are the finite, then it must be existence for the uniform continuity. Next shortcut trick says if f is my differentiable function such that f is my bounded, and this condition implies that f is my Lipschitz continuous, then you can say f is always my uniform continuous. And the last tip is if you prove that the function is continuous and periodic, then it implies f is my uniform continuous. Based on these four tips, I can solve each question in a very simple manner in this lecture. On the second hand, if you are thinking about the uniform convergence, like how you can check about the uniform convergence of the sequence, how you can check about the uniform convergence of the series, I will not cover this topic in this today's lecture because today lecture is the uniform continuous. If you want to learn how you can check about the uniform continuous and the uniform convergence of the sequence and series, you must watch about my these two lectures. If you are new to my YouTube video, you can scan and join my WhatsApp group. Now look at this one. F is a mapping which are defined on the open interval 0, 1 to R. Which of the following is my continuous? What is the properties? You need to prove that f is my continuous, and because it's open interval, your target is to prove lower limit of the 0 positive and lower and the upper limit 1 negative must existence, because the limits are, because the intervals is my finite, so it must exist. Firstly, you can see this is the a comma b is my continuous function. Fine. This is also my continuous function. This is also my continuous function because the open interval. This is also my continuous interval. Now, look at that. When you take 0 positive of the 1 by x, it goes to the infinity. That means not exist. So once it is not exist, it is not uniform continuous. Look at the second case. If you take the limit of the 0 positive of this case, it's a 0 by 0 form, then I can apply the L'Hopital rule. Then it will goes to the 1, which is unique and existence. Fine. Now look at the second 1 negative. If you taken as a 1 negative, then it will be sine 1 over 1, which is again unique and existence. So therefore, this is my uniform continuous. Look at this third case. If you take the limit as x approaches 0 positive, then this number will be my sine of infinity, but sine is my bounded function. It lies between -1 to 1. Clearly say this limit is my not unique. Once the limit is not unique, that means this is my not existence. So therefore, this case is cancelled. Look at this case. If you take the limit as x approaches 0 positive, cos 0 will be 1, sine and divided by x, that's the infinity. So which is not existence. Therefore, the correct option of this problem is my only B is the right answer. Again, you can see the second question is from the 0, 1 to r. Clearly say this is my continuous function. This is my continuous. This is my continuous. This is my continuous. All are my continuous. Then as x approaches 0 positive, this limit will go to the infinity. That means it is not existence. Therefore, the first option is cancelled. Look at the second option. It is 0 into any number which are lies between -1 to 1. This will always goes to the 0. That will give the finite and existence. If you take the limit as a 1 negative, it will be 1 sine 1 over 1, which is again the finite and existence. So therefore, this is the right answer. Look at the third one. If I take 0, then it will be the sine of infinity, which gives you the -1 to 1. That means not a unique number. Once it's not a unique number, it means the limit does not exist. If I take sine x over x, as x approaches 0, this value will goes to the 1, which is unique and finite. And when you take as a 1, it will be the sine 1 over 1, which is again finite and unique. So yes, B and D are my right answer. Again, you can see a function which is uniform continuous on the open interval. So 0, 1 is a continuous. This is also continuous. When you take continuous and all continuous. If you take this first part will goes to the 1 as x approaches 0 positive, which is finite, and it goes to the 1 if x approaches 1 negative. In the both the case, we will get a unique and finite answer. That means existence. When you take 0, it's a 0. When you take 1, it's a finite answer. Clearly say when you take as a 0, tan 0 will be 0, which is finite, but it will go to the infinity as x approaches to the 1 negative. That means it is not existence. So third option is cancelled. When you take 0, it will be goes to the sine 0 is my 0, which is my unique number. And if you take a 1, it will goes to the sine 1, which is again the unique and finite. So yes, the right answers are A, B, and D are my correct answers. Look at this another one. Again, this is the open interval. Again, you can see clearly all these options are my continuous. Fine. Now we will see this will go to the infinity. That means it is not existence. The first option is cancelled out. When you goes to the 0, it will go to the sine of infinity. That means the answer is not unique. That means limit does not exist. That means the option is cancelled. it is my 0. Any number lies between -1 to 1, that will goes to the 0. That's a finite and the unique answer. And when you goes to the 1, it's a sign of 1, which is again the unique and finite. That's the right answer. This will goes to the 1 as x approaches 0, because it's a 0 by 0 form. You can apply the L'Hopital rule, and it goes to the sine 1 over 1. That is again finite and unique. That means the correct options are C and D. Dear student, if you look about these all examples, clearly say they are the repetitions. That's why the PY questions are always necessary before going to the next examination. I hope you can like and comment on my video. Again, you can see this is my not a unique number. When x approaches to the 0, fine. When x approaches 0 positive, this will be cancelled out. This function is e raised to power -1 over x square. If I take the limit as x approaches 0 positive, this will goes to the e raised to power minus infinity 0. That's a finite answer. But if you take the limit as x approaches 1 negative, this number will goes to the e raised to power -1, which is also the finite answer. Yes, this is my uniform continuous. This number, if you take x approaches 0, then it is cos of infinity. E raised to power 0 is 1, but this is my -1 2 plus 1. That will give you not a unique answer. That means limit does not exist. If I take 0, then it will be the cos 0 into cos of infinity. Cos 0 is 1. Cos infinity is any number lies between 1 and -1. That's again not a unique. So the right answer is only B is my right answer. And you can see this is a very recent year paper, and you can get your answer with the help of the 10 to 15 second time. Don't forget to like and comment on my video to support my efforts. I did my all efforts only for you, so kindly support my videos by liking, comment and share on this video. Again, you can see it's open interval. This is goes to the infinity as x approaches 0, so not uniform. Again, you can see it's a bounded function, so this will never give you the unique limit. Fine. So again, it is not a unique, not a uniform continuous. This will go to the 0 into any number between, so that will go to the 0 unique limit, and when you taken as a 1, it's a 1 into sine 1, which is again a finite and the unique. Yes, this is the right answer. This will go to the 0, then 0 cos 0 will be the 1. So 0 by 0, that's a 1, that's a unique, and when you take n as 1, it's a sine 1 over 1, which is again a unique answer. So the right answer is C and D are my correct answer. Since now you can see that all these questions I have explained with the help of the R to R. But if you are interested to find how you can check about the continuity and differentiability of the function of several variables, you must watch about my these two lectures. And if you want to find about the differentiability, you can find these lectures available at my YouTube channel. Now, look at that the function is by uniform continuous. It is given that function is by uniform continuous. That means limit x approaches 0 positive f existence, and limit, because this is not a finite number. If this is not a finite number, this may or may not exist. Fine. This may or may not exist. But because 0 is my finite number, so that means this must be existence. So look at that. Need not exist. Neither exists. Fine. Now the first option said always exists, but the option is may or may not be. So that's why that first option is cancel out. You can see if I define the function from this is my uniform continuous, fine, on 0 comma infinity, but you can see as x approaches plus infinity of the f, which is not existence. That means he said existence. That's a cancel. Right option is B is my right answer. Make sure student, if the limit goes to a or 0, if this is finite, then it must be existence. If it goes to infinity or minus infinity, it may or may not existence. Another example, you can say it's a sine x, because we know that sine x is my uniform continuous on 0 comma infinity. but clearly say if you take the limit as x approaches infinity, it's a sign of infinity. So that means any number between -1 to 1, not a unique number. That means limit not exist, but it is still uniform continuous. Okay, look at this another one. F is a function which are defined like this manner. What does it mean? F is bounded and ellipse is continuous. Once f is bounded and ellipse is continuous, f is my uniform continuous. If f is uniform continuous, this implies f is my continuous as well. Now, if f is uniform continuous, then f map bounded sequence to the bounded sequence. Yes. If f is uniform continuous, then f map Cauchy sequence to the Cauchy sequence. Correct. If f is a convergent sequence, uniform continuous, f map continuous Cauchy sequence or convergent sequence to the convergent sequence. If f is a mapping from R to R such that fx minus fy is less than equal to x minus y raised to power beta, where beta is my strictly greater than 0. Then first option is if beta is equal to 1. What will happen? Fx minus fy is less than equal to x minus y. Then f is differentiable. Can you think about any of the non-differentiable function? First of all, what comes in your mind when we are always talking about the non-differentiable? Can you provide me any example which is non-differentiable? Mod x. Fine. Now you can check whether this property is satisfied or not. Mod x minus mod y. We all know this is always less than of the x minus y. So that means this will satisfy the given requirement. So is it a differentiable? This is not differentiable. The first option is cancelled. Fine. Now beta is equal to 1. So in this case, it's now in this case we will see beta is equal to 1 because beta is greater than 0. Then what we can say about this side? Now I can divide it both side by x minus y, mod of x minus y. This will be less than equal to 1. Now take the limit as x approaches y. This will goes to the f dash is less than 1. That means f is bounded and uniform continuous. That means f is bounded and ellipse is continuous. Once f is bounded and ellipse is continuous, that means f is my uniform continuous. So if beta is equal to 1, that's a greater than, it is my uniform continuous. Beta is equal to greater than 1, then it is a constant function. I can choose any function, say beta is equal to 2. Fine. Then fx minus fy is less than equal to x minus y whole square. Again, I can divide it both side by x minus y over x minus y, which is less than of the x minus y. Then take the limit as x approaches y. The left hand side will be, this will be 0. So that means f dash of x will be less than 0. But we all know modulus value can never be 0, less than 0. That means derivative is 0. If derivative is 0, that means f is my constant function. F must be the polynomial. F must be the polynomial. Now in this case, beta can be any number. Assume that beta is 1 again. That's a very simple case. That means fx minus fy is less than of x minus y. Now clearly say, as I proved in the first part, mod x satisfy this case. Fine. But clearly say mod x is not a polynomial. Fine. So this option is cancelled. Or you can choose any other example, say sin x. We all know sin x minus sin y is less than equal to x minus y. So this equation satisfied. But again, you can see this is my not polynomial. So the right options are my B and C are my correct ones. Now you can see again fx minus fy. Again, you can see sine mod of sin x I can written as less than of x minus y. Then I can divide it both sides by x minus y and take the limit as x approaches to the y. That means f is my uniform continuous because it is my Lipschitz continuous. F is my uniform continuous. Once f is uniform continuous, it defined on the open interval. That means x approaches 0 positive and x approaches 1 negative. Both exist, must exist because they are the finite limit. Now it is my distance. Now since f is uniform continuous for all x in the R, that means f is continuous for all x belongs to the R. But he said f is discontinuous. F is continuous everywhere in the open interval, but not uniform continuous. Wrong answer. C and D are my right answer. Look at this another one. Again, it's a simple because we all know cos x minus cos y. I can also written as x minus y. Again, I can divide it both sides by sine. I can also divide it by mode of x minus y. Again, you can see f is my uniform continuous. Again, it defined on the open interval. So that means the limit must be existence. If it is a uniform continuous, that means f is my continuous. So f is continuous everywhere, but not uniform continuous. Cancel. F is discontinuous. That is wrong. Again, you can see C and D are my right answer. You can see it's a December 2015, it's a June 14, and you can see it's a June 2030. That's why the PY question is a very important to solve before going to examination. Always a repetitions kind of the question asked. Kindly like and comment on my video to support my efforts. I did my efforts only for you kids. F is a mapping from 0 to 2 pi to R2. G is the mapping from 0 comma 2 pi close interval to R2, which are defined like G of x is cos of t, sine of t, and same which is defined as f of t is cos of t and sine of t. Fine. Then which of the following are continuous, uniform continuous, uniform continuous? Firstly, I will tell you the shortcut tips. Why? Because it is defined on the R2. Whenever you have a function like h1, h2, h3, like cos, comma, sine, and so on, if each of the hi is my continuous, then if I call this is my capital H, then the composition function h is also continuous. Fine. Because I need to prove the uniform continuous, the first thing we need to check that whether G is my continuous, F is my continuous. Now you can see cos of t is my continuous on this closed interval. Sine of t is my continuous on the closed interval. That means G is my continuous on the closed interval 0 comma 2 pi. Now, as I told you in the earlier tips, if it is defined on the closed interval and G is my continuous, then G is my uniform continuous on the closed interval 2 comma pi. So G is not a uniform continuous, cancel. G is continuous, fine. G is uniform continuous, D option, cancel. Fine. Now, look about the F. Again, we will need to check because F is defined on the open interval. So I have to satisfy both the properties. Firstly, we will see whether it's a continuous or not. What is the value of the F at 0? What is the value of the F at 2 pi? What is the F of 0? Because 0 equality occurs, so I can compute from here. Cos 0 is 1, sin 0 is 0. Now, 2 pi is not the part of this domain. That means the function, whenever t is defined in this case, the number will be my cos and sine. Otherwise, it's a 0. So this part will be my 0. Now, how you can check about the continuity? We will see about 2 pi negative and 2 pi positive. If we obtain both the limits as a 0 comma 0, because it's a 2 tuple, I can say 0 comma 0. What is the value of the 2 negative? 2 negative lies in this case. 2 positive is also 0 comma 0. So what is the 2 negative? Cos of 2 pi 1, sin 2 pi 0. Clearly say they are my not equal. That means f is my not continuous. So if f is not continuous, this implies f is my not uniform continuous. Make sure, student, as I told you in my earlier tips, whenever you have the open interval a comma b to say r, you have to prove the two conditions: f is continuous and their limits on the a negative, a positive, and the limit of the b negative exist. Since the first property does not hold, that means f is not continuous, implies f is not uniform continuous. So b is my correct answer of this problem. There is nothing to do think about anything. Just remember, if it is a closed interval, then only the continuity is fine. If it is an open interval, then check about the limits and the continuity. The function f is defined like this method. Okay. Now it's a very, either you can integrate it, you can substitute sine of t is my y and then solve it. Otherwise, I can check about this derivative. How you can derivative them? I can use the Leibniz tool. What is the Leibniz tool is? I can substitute the upper limit 2 sine raised to power 4 into x cos square into x into derivative of the upper limit minus I can substitute the lower limit 2 sine of 0 is 0 cos of 0 1 into derivative of this lower limit. So what is the f dash? F dash will be 2 sine raised to power 4x cos square x. That means mod of f dash is less than equal to 2 because sine and cosines over this interval is less than 1. That means f is my bounded and Lipschitz is continuous. So if f is bounded and Lipschitz is continuous, that means f is my uniform continuous. If f is uniform continuous, that means f is my continuous. So first option is not continuous, cancel. Not uniform continuous, cancel. Not Lipschitz continuous, cancel. The right option is D is my right. Just try to think about my simple shortcut tricks. You can solve each problem in this same manner. You can analyze till the last whether it's an examination of the gate, whether it's an examination of the CSIR NET. I use the same shortcut trick. Now, f is my continuous function such that x plus 1 is my fx. If you watch my previous continuous lecture, I gave you the tips that you always start from the e raised to power x or 1 or x. Look at that, which one will satisfy this function. Clearly say f of x is 1 will satisfy this property. Fine. Now f of x is 1 is my bounded function. Fine. What is the lower? What is the lower bound? Lower bound is 1. What is the upper bound? Upper bound is also 1. Look at that. F is bounded above but not bounded below. This is the one counter example which discard this option. F is bounded above and bounded below but may not attain the bound. Can you choose the value of the x so that it will be 1? It has infinitely many x. F of 3 is equal to 1. F of 4 is equal to 1. So yes, you can attain the bound. F is bounded and above and attain the bound. Yes, F is uniform continuous. But this is a one counter example. You can't say about the continuity or you can't say about its boundaries. Now, look about this function. Which things come in your mind when you think about this function? Like x plus something is fx. Now I think you can think about that. Yes, that is f is periodic function. So if f is periodic function, what is the period? Period is my 1. Fine. Now if you remember my earlier shortcut tips that I mentioned you, the 4 shortcut tips, if f is my continuous and periodic, what does it mean? It is my uniform continuous. Fine. Now can you think about any of the periodic function? Always think about the sin x. What is the period of the sin x? Sin x has the period 2 pi. What is the period of the sine 2x? Because I need a period 1. How you can make them? What is the period of the sine 2x? It's a 2 pi over 2. The period of the sine 3x is 2 pi over 3. So can you think about the function whose period is a 1 and in terms of the sine it will be sine of 2 pi x. Now again you can see it's a bounded function. The minimum and the maximum value is my -1 to 1, but it is not bounded. Cancel. And you can easily attain the bound. Yes. So the right answer is C and D are my correct answer. Okay, now you can see it's a December 2023. Again, you can solve it in a very simple manner for a real numbers A, B, C, D. Because answer is not dependent on the A, B, C, D. I can choose all the values as a 1. Fine. Then, which of the following statements is my continuous, differentiable, and so on. What is the earliest? What is the shortcut text? As I told you, you can see this. I can use the same. If each of the functions are my continuous, then their composition is also continuous. Now you can see about the same. This is my linear. Fine. This is my linear, which are my continuous. In this case, they are my two function h1 and h2. H1 is my linear, which is a continuous. H2 is my linear. This is continuous. That means f is my continuous. Fine. F is differentiable. If each of the hi is my differentiable, then this is my h, then capital H is also differentiable. Fine. So h is differentiable. We all know if h is my differentiable, then all the partial derivative exist. Fine. So all the partial derivative exists, but make sure the converse is not true. If the partial derivative exists, we can't say that it is differentiable. Now, how you can say about the uniform continuity? We need to check the two properties. The first one is f is my continuous. That I already proved that. Second is whatever the coefficients, that is a B, C, D, E, F, they are my bounded. If they are my bounded, then it is my uniform continuous. Now you can see I have taken all as in 1 and 1 is my bounded. Fine. So that means it is also correct options. All are my right answer of this problem. And you can see it's a December 2023, 4.75 marks is the question, and you can get a right answer within the 10 seconds. If you watch my all those previous PY question series available in this playlist, all these shortcut tricks as I explain you already in my this PY question series. Okay, look at this another one. G is my continuous function, G is my uniform continuous, and so on. So your target is to check the function is continuous on 0, 1, comma 0, 1. I can define the pair. It's a 0, comma 0. It's a 0, comma 1. It's a 1, comma 0. And it's a 1, comma 1. You can see whether it's a gate examination, whether it's a CSIR examination. My approach is similar, whether it's a net, gate, or TAFER or any of the examination. What is the condition for the uniform continuity? Function is continuous. Since it is an open interval, you need to check about the limit is existence. Fine. Now, when this is the first function is my x, this is the y. If x is 0, y is 0, what is the value of the f? 1. Fine. Fine. What is the value of the g? 1. Both are fine. Look at this case. What is the value of the f? When x is 0, y is 1, it's a 1. What is the value of the g? Again 1. If x is 1, y is equal to 0, answer is 1 over 2. If f x is 1, y is equal to 0, answer will be infinity. That means not exist. So if g is my not exist, that means it is my not uniform continuous. So f and g both are uniform continuous. G is my uniform continuous answer. Look at the last 1 and 1. If it is 1 and 1, f will be my 1, g will be, if 1 1, it's a 1. Now clearly say f, it is a finite, f is my finite, f is my finite, f is my finite. It means f is existence for each case. So that means f is uniform continuous. That means f is uniform continuous but not. So B is my right answer of this problem. There is no need to think about the any of the standard definition like fx minus fy. Just think about the simple my shortcut tricks. Don't forget to like, comment, and share this lecture with your friends. Okay, look at this another one. F is the mapping from R to R defined by this manner. Capital T is given to be this. F is uniform continuous on usual matrix. Now, do you remember that? What is the usual matrix on the R? Yes, anybody? Yes, it's a discrete matrix. Fine. Discrete matrix is called as the usual matrix on the R. And we know that any function on the discrete matrix, any function on the discrete matrix is uniform continuous. Fine. Any function on the discrete matrix is a uniform continuous. So that means n is my uniform continuous. Fine. So n is my uniform continuous. This n is not neither. Fine. Now you can check about the capital T. So capital T is defined as n union n plus 1 over n. Now you can choose any 2 point, x and y. You can choose any number. Say x is my natural number and y is my from this number. Fine. Then you can easily see that what is the value of the fx minus fy. Firstly, what is the x minus y? X minus y is my 1 over n, which goes to the 0 as n approaches infinity. Now your target is to prove whether it goes to the 0 or not. Fine. Now what is the fx minus, what is the fx? X belongs to the n is my natural number. So when n belongs to the natural number, fx will be my n. Y is not my natural number. So then if y is not natural number, it will be my 0. So the answer is n. It goes to the infinity, but not 0. So that means it is my not uniform continuous. So both are cancelled. Only A is my right answer. So you can see it's a very simple approach. You can get your answers. Okay, f is defined as 1 over root x for x belongs to the open interval 0 comma infinity. Fine. Then it's a uniform continuous or not. So check whether f is continuous firstly. Is it f is continuous on the open interval? Yes, because it can never be goes to the infinity. So f is uniform continuous. Fine. Then because this is my finite, so your target is to check 0 positive f must existence. What is the value of the 0 positive is infinity. That means not existence. Fine. So it means on 0 comma infinity is not a uniform continuous because this is my finite. Fine. If it's a infinity, it may be finite or may not be. But at the point 0, because 0 is a finite number, it must be existence. So that option is cancelled. Similarly, on this case, it option is cancelled. Now, look at the second option. If you think about closed interval r, comma infinity, r is my greater than 0. So again, check whether the function is continuous on this interval. So since the function is continuous on the closed interval r, comma infinity, fine. Then what is the limit of the x approaches are positive? This is my 1 over, which is my finite. Why? Because r is my strictly greater than 0. And we can see about infinity. So once is a infinity 0, which is also finite. Now f is continuous. Both the limits are finite. That means f is my uniform continuous. Look at the last option. The interval of a comma b, where a is strictly greater than 0, b is strictly less than infinity. So clearly say f is my continuous because now it's a closed interval. So your target is to check only about the continuity. Now f is my 1 by root x. It's a continuous. That means f is uniform continuous also. But you can see they are talking about only on the interval. That's wrong because we got the interval as r comma infinity. So the right answer is B is my right answer. This option is cancelled because of the only. If this only is not be mentioned, then it is also the correct. Okay, let f is the r to r. There exists epsilon. So your target is to existence of the epsilon. Then such that x minus, okay, this is just like say continuity, discontinuity, uniform and so on. Can you think about the function is continuous? Can you think about any of the discontinuous function? Very simple. You can choose any point. X is non-zero. X is 0. Then what is the fx minus fy? Fine. What is that? If both are my 0, x and y both are 0, then answer will be 0. If both are non-zero, then again answer 0. If x is 0 or y is non-zero, then answer will be 1. Fine. So clearly say it will be less than of epsilon. If I choose epsilon is 1.3 or 1.5 or 2, any number. So there exists. Fine. X minus y definitely is a less than of delta. Fine, because delta is positive. So that means this f satisfied my given requirement. Then is it a continuous? Clearly say f is my discontinuous function at 0. So f first one. If f is my not continuous, what does it means? F is my not uniform continuous. Is this a constant function? Is it bounded? Yes, f is my bounded function. But based on this example, we can never say that third is correct option. F is constant. You can see f is my not constant function. Constant happen only if this value is 1. If this is 1, then it's a continuous. Fine. So right now it is my not a constant. This option is cancelled. So the only left behind is my C is the correct answer. And how you can prove that it's a bounded? You can see my target is to prove mode of fx should be less than of m. So I can start from this number. I can write this is fx minus fy plus fy. Fine. I can return this number is fx minus fy, or instead of the y, I can choose an as any real number, say a. Fine. This is my a plus f of a. This number is my less than epsilon plus f of a. So f is any number from the R to R. Clearly say which is less than of the m. That means it is bounded. So that's why C is my right answer. But make sure your target is always to discard the 3 options and you will get the right answer. Don't forget to like and comment on my video. So f and g are mapping from minus infinity to plus infinity to minus infinity plus infinity. Then f is my x square and it is my sin x. Fine. So clearly say this is my not UC. It's not a uniform continuous. This is my uniform continuous. Because in this case it's a minus infinity. Fine. It's a continuous. Both are my continuous, but it's not a uniform continuous. Now, which are the following? So let me firstly write the function g of fx sine x square. X square sine x. It's a sine f x square, sine of x square, and this is x square plus sine. Clearly say this is my not uniform continuous because x square is my not uniform continuous. Fine. Look at the first question. Firstly, I will give you the shortcut tips. The first one is the composition mapping. G of fx. Fine. If this function inside function is my uniform continuous, g is my bounded function, then this is my uniform continuous. Now you can see g is my bounded, sin x is bounded, fx is x square, but x square is not uniform continuous. So that means this is my not uniform continuous. Look at this third option. You can see sin x square. This is my bounded function, or yes, it's a bounded function because you can see if you derivative them, it will be my 2 sin x cos x, that will sin 2x, it is less than 1. If this will be less than, it means h is my bounded and satisfy the Lipschitz continuous, that means h is my uniform continuous. Since x square is my not a bounded, it's not a uniform continuous, so and it's from minus infinity to plus infinity, that means this is my again not uniform continuous. So The right answer is only C is my correct answer of this problem. Student, remember this very beautiful shortcut tricks. You can solve this problem whenever there is a composition method. Okay, which of the following statement is true? F is a mapping from R to R. G is also a mapping from R to R such that f of x is e raised to power minus x. Check whether this is my uniform continuous. Both G is only uniform continuous and so on. Okay, how you can see about, firstly we can see about the G. Firstly, e raised to power minus x square. Clearly say this is my continuous on minus infinity to plus infinity. Check about the limit minus infinity. Check about the plus infinity. If they are finite, then it is my uniform continuous because the function is continuous. So what is the limit of this? When you take as a minus infinity, this will goes to the minus infinity, that's a 0 which is finite. If you take as a plus infinity, it is again infinity, so that's a 0 which is again finite. It's a continuous because it's the open interval. R is my open interval minus infinity. It's an open interval continuous finite. That means G is my uniform continuous for all x. So G is my uniform continuous for all x. F is a uniform continuous. G is a, now we can look about the F. Again, e raised power minus x is a continuous function. Now, firstly, we will see what is the limit. X approaches minus infinity of the F. Limit x approaches plus infinity of the x. If they are finite, then we can say it's a uniform continuous. If they are not finite, then we can't say anything. What is the x approaches minus infinity? This is e raised to power plus infinity. That is a not finite. But we can't say anything because if the limits are my finite, if this intervals is my finite, then only you can say. So that means we can't say anything about this continuity. How you can check about the continuity? I can found the derivative. Fine, e raised to power minus x. Then limit x approaches minus infinity of f dash. It will be e raised to power. It will goes to the minus infinity. What does it means? F dash is my unbounded. Fine. If f dash is unbounded, that means f is my not uniform continuous on this interval. This is my R. But we will see what is the limit of the x approaches plus infinity of the f dash. If you take a plus infinity, this will goes to the 0. That is a bound. Fine. But R contains minus infinity as well. So that means this is my not. Now you can see on the infinity, plus infinity is a finite. Fine. Also, alpha is a closed interval. So that means if I choose as a alpha positive of the f, it is my e raised to power minus alpha. Fine. And that is my finite answer. So that means f is my uniform continuous on the closed interval alpha comma, because infinity is my finite, it's a bounded, it's a finite number. So that's f is continuous on every interval of this form. Look at the last case, whether fx into gx. Fx is my e raised to power minus x, e raised to power minus x square. If I call this is my h, so h will be e raised to power minus x plus x square. Now clearly say this function is my continuous on R. Fine. And again, we will see the limits. Limits approaches minus infinity. Limits approaches plus infinity. If they are finite, if both are finite, then it's a uniform continuous. If they are not finite, then we can't say anything. So let's say it's a minus infinity. Firstly, we can take a plus infinity. It's a infinity plus infinity. Infinity, that is 0, which is fine. But if you take as a minus infinity, then it's a minus infinity plus infinity. Again, you can't say anything about that. So in that case, I can take an x square as a common, 1 over x plus 1. That means it is my minus infinity, 0 plus 1, 1. That means 1 over infinity is my 0, which is again finite. In both the cases, we get a finite. Yes, it is my uniform continuous. So right answer is B, C, D are my right answer of this problem. Make sure, student, whenever there is a question of the uniform continuity, always check about the limits. Okay, look at this another one. F is my periodic function. Fine. So that means if I prove that f is my continuous, what does it mean? F is my UC. Fine. Now, what is given to you? F is 1 minus 2x minus 1. Clear? X belongs to the closed interval 0, comma 1. Clearly say, because mod x is a continuous function, 1 is my continuous function, f is my continuous function. Fine. So if f is my continuous function of the 0, comma infinity, f is my bounded function of the 0, comma infinity, that means f is my uniform continuous on the 0, comma infinity. There is no need to apply the limit at 0 positive and alpha infinity negative. Now G is my continuous or not. Again, you can see this is my composition map. If I prove that this is my uniform continuous, f is my bounded, fine, then it is my UC. First of all, f is periodic, f is continuous, implies f is UC, so it means it is my bounded. That means f is bounded, fine. Now your target is to prove f, sorry, f is already given, I call as the h. H is my function defined on closed interval 0, comma 2r defined by x square. Now clearly say this function is my uniform continuous. Fine, because it's a continuous, fine. If you take as a limit 0 positive, it's a finite. If you taken as infinity, it may or may not exist, but it's a uniform continuous. It's a uniform continuous. So and gf is my bounded, that means G is my uniform continuous. If G is my continuous, uniform continuous, this implies G is my continuous as well. So the C, all are my right answer of this problem. And you can see this is the December 2023. Again, 4.75 marks. You can get your answer in a very, very simple approach. You can get your answer in the 10 to 15 second time period. There is one more method that directly come in my mind right now. How you can check about the continuity? Like some student may think that how you can define the gx. It is f of x square, 2x square minus 1. Fine. Now clearly say, because mod is my continuous function, so that means g is my continuous function. Fine. So that's other way. Otherwise, if you know it's a uniform continuous, you can easily say it's a uniform, it's a continuous as well. Okay. F is the mapping from A to R defined by f of x is equal to x square. Then f is uniform continuous. It is given that this is given to you. Fine. So firstly, I will tell you the shortcut tips and then I will tell you the right answer. If f is a mapping from A to R, where A is my subset of the R, such that f is my uniform continuous. This implies, what can you say about that? If f is my, or you can say f is my bound. Fine, because f is my uniform continuous, implies f is bounded, that means f of a is my bounded. If f of a is my bounded, that means a is my bounded. Fine, it's a bounded subset of. Now you can see it is given that f is my uniform continuous. This means f of a is my bounded, that means a is my bounded subset of R. Now look at the other options. If I simply take A is equal to R, fine, then what is the mapping is R to R defined by x square. We all knows that this is my not UC, fine. but it means this is the UC. That means A can never be R. That means if I take A is equal to R, A is the dense subset of the R. A is my unbounded connectivity because R is my dense. You can see because we all know R is my dense. Fine. R is also my unbounded. Fine. R is also my connected. Fine. And R is also my open subset of the R. If I simply take A is my R, A is my R, then these three options are cancelled out. Only right option is A is my right answer. Look at this another one. F is a mapping from A to R, which is given as a uniform continuous. That means F of A is my bounded. So first option is correct option. F is necessary continuous. Can you think about any of the function which is a uniform continuous? I can simply take x minus 1. Fine. Clearly say this is a continuous. If you define it as any interval, it is my limit existence. So this is my uniform continuous. Now you can see f is necessary constant. This function is not constant. This function is not differentiable. Mod x is not a differentiable. It is not a differentiable. Right answer is only A is my correct answer. Okay, f is defined like A over B plus x square. F is uniform continuous, uniform continuous, uniform continuous. All are my uniform continuous. Firstly, we need to check whether it's a continuous or not. Because B is my strictly greater than 0. That means 1 plus bx square is always greater than 0. Because x square is always positive. This is always positive. And 1 plus x square is by this number. A can be any number. So that means this function is my well-defined. Fine. Now, once it is my well-defined, clearly say f of x is my continuous on the R. Fine. Now, because it's a R, that means minus infinity to plus infinity, I will check whether the limit from minus infinity of the f and limit of the x approaches plus infinity of the f are finite or not. If both the limits are finite, then we can say it's a uniform continuous. When x approaches minus infinity, this becomes a 0. Oh, sorry, this becomes infinity. Anything upon infinity is my 0. Anything upon infinity is 0. Both are my finite. That means f is my uniform continuous for all the values of the a, for all the values of the b in my R, because there is no restriction on the a and b. F is once is f is uniform continuous, then f is uniform is all R, then it's also the continuous on the subset of the R. So yes, A option is the correct option. F is a uniform continuous on R and it is bounded, but we will check the bounded. F is a uniform continuous only if B is equal to 0. But we prove that it is for all B. And it is my unbounded. Now we will check about the unbounded. That's how you can check about the unbounded. If I start with the modulus, then it is A over 1 plus bx square. It is always less than of the A, because 1 plus bx square, b is always positive, x can be any real number, so that x square 1 plus, we all know 1 plus bx square is always be greater than of the 1, so 1 over 1 plus x square is always less than equal to 1. So that means mode of f is less than of the A is my real. But if it is an infinity, what can you say about that? If A is by infinity, what can you say about that? It's unbounded. So that means how you can prove that bounded or unbounded. If A is my non-zero, then if A is my non-zero, then A can be infinity, then it's unbounded. But it is for all values. We will see about the how you can check about the boundedness. I will start about the derivative minus 2abx over 1 plus bx square of square. Fine. Then if I prove that the maximum value is if I prove that it's a less than of something, then it is my uniform continuous, then it is a bound. Fine. Now, okay, because B is my positive, so I can assume either A is my positive or A is my negative. If A is my positive, then what is the value of the f dash? It depending upon whether x is positive or x is negative. If x is positive, A is negative, B is negative, denominator is always positive, this number is less than 0. If x is negative, A is positive, this number is always positive. So if you want to draw the graph, this is my A. If x is negative, this value will be increasing. Fine. So that means the graph will be like this manner. If x is greater than 0, the graph will be decreasing. That means this manner. But what about the 0? If x is 0, what is my fx? If x is 0, what is my fx is A, and A is my strictly greater than 0. So answer is this one. That means the graph will goes to this and then decreasing. This is the graph of the f. What does it mean? F will lies between 0 to A. Fine. So that means in this case it is my bounded when A is my greater than 0. But we have to consider the second case also. If A is my less than 0, what is my f dash? Again you have the two cases. If x is my greater than 0, A is my negative. So this is my positive and this is my negative. Again you can draw the graph. So if x is my positive, the graph will be increasing. So the graph will be increasing. That means it will be like this manner. Firstly, we can see if x is 0, what is fx is A, because A is negative, it will be negative. And whenever x is my greater than 0, it is increasing. Whenever x is, it's a decreasing. Fine. So this number is my minus A. Fine. So in that case, the limit will be, the value of the function will be this case. And you can see in this case, the function is my bounded. In this case, function is my bounded. That means the function is bounded for all values of the A and B. It is not true for non-zero. So the right answer is A and B are my right. Okay, look at this one. Okay, again you can see we can start with the derivative. This is my sine square x square into 1 g. Fine. Now what is that f dash? This is my 1 because sine is my bounded. So that means f is my bounded and Lipschitz continuous. So this implies f is uniform continuous for all x. So f is uniform continuous on this. This is the subset of this, fine, but not on this. That's wrong because it's true for all. It is not true. It is uniform continuous for all. Neither the uniform continuous. C is my right answer of this problem. You can see again the gate, net all have the same approach I have solved. Don't forget to like and comment on the video. Okay, A is my continuous function. If f is my uniform continuous, what does it mean? Fx minus fy is less than of alpha times. It satisfies the Lipschitz continuous. Now you can see for every value of the, or I can say this number is say 3. Again you can see if I divided both sides by x minus y, it will be say any number of the beta over x minus y. So clearly say this is my less than of, fine, that's a boundary, that's a uniform continuous. First option is the correct option. Second option, if for every C and D subset of A comma B, I can choose A is my 0 because A and B have any number, fine. C and D any interval of this, so I can choose as a 0 0.1, 0 0.2, fine. If f restricted to the C comma D is uniform, you can define the f from C comma D to R is uniform continuous. That means it's a closed interval. You have to define a function which are my continuous. This is a continuous, that means a UC. But f is uniform continuous also on the, so can the interval, is this function is also uniform continuous on a 0 comma 1? Yes, but but we can't provide the one this way. If I choose the 1 over x, fine. Now clearly say again this function is my uniform continuous on the closed interval because it's a continuous. Also 1 of x is my continuous on the closed interval 0, 1, but you can see the limit of the 0 positive f does not exist. That means it is not uniform continuous. F is uniform continuous on the closed interval, but not on the uniform continuous. Look at the third option. F is strictly increasing. If f is strictly increasing on this interval a comma b, that means limit x approaches a positive, limit x approaches b negative. Both are existence and bounded. So that means if f is monotonically increasing, f is monotonic and bounded, that means f is my uniform continuous. If f is a continuous, uniform continuous, that is the last option. If f is uniform continuous, then f map Cauchy sequence to the convergent sequence. We know if f is a uniform continuous, f map Cauchy to the Cauchy, but on the R, every Cauchy implies convergent. So that means Cauchy implies to the convergent. So the right answers are A, C, and D are my right answer of this problem. Okay, look at this another one. I is the subset of the R. Then F is my uniform continuous. It is similar of this category. Fine. If F is my uniform continuous, that means F is my boundary. That means I is my boundary. Fine. I is my closed. You can simply choose I is equal to R. F is the mapping from R to R. G is a mapping from R to R. I can define the function x. G is my x, which is my uniform continuous. Fine. Then H is my x square, which is not uniform continuous. So that means I is closed, cancel. Fine. Now I will give you these two options. You can verify by on and let me know which one is the correct option in the comment box. You have to provide the correct explanation so that I can understand it. You have learned this lecture very deeply. Let me know your answer in the comment box so that I can understand you have understood this lecture very well. Otherwise, I will tell you the answer in the comment box later. I hope you can like, share, and comment on the video. We will upload the next lecture on the differentiability. Till then, you can like, share, and comment on it. Happy learning, students. Best of luck.